Hello everyone, today I will be providing solutions to starter 189. So this is the first problem. In this problem we are given n food items where we are given vitamin AI and we are given a cost BI and also integer parameter C which denotes the value of single vitamin to us. So I will copy paste this test case and let you understand what does this mean. So in this test case the value of n is 5 and the value of C is 6, and it's given to us that we have to buy food items such that we can maximize the value of Cx minus y, where x is the number of distinct vitamins we can eat. So this is telling us that for each unique vitamin we will add C minus the cost to our answer. So our answer will be equal to C minus y for each of the unique vitamins which we will choose. To maximize this value, we will choose the minimum value of the cost for each unique vitamin. So we will iterate over all the vitamins and will calculate the minimum cost for each unique vitamin. So in this case, for 3 the minimum cost will be 7, for 4 the minimum cost will be 4, and for 2 the minimum cost will be 1. Here we are given the value of C as 6. So taking the third vitamin will cost us minus 1, as 6 minus 7 will be minus 1. So we will not consider this case. We can consider the other two as they both are less than C. So our answer will be C minus y for all the vitamins where the cost is less than C. So in this case the answer will be come out as 6 minus 4 plus 6 minus 1, which comes out as 7. So I'll just quickly go through the code. So first I'll take the input, both the integers n and c, and both the vectors a and b. After that I will create a map which will store the minimum cost for each unique vitamin. In the first case it will be the first cost, so I will directly store in the map, and for others I will take the minimum and store it in our map. Then I'll iterate through my map and find out whether the cost is less than C. If it's less than C, I will add it to our answer and then return our answer. So this is the second question where we have to create a binary string of length n, and in n there will only be zeros and ones. We have to maximize the number of coins which we can get using this string, and the number of coins we will get is through zeros, ones, 0, the sequence of 0 and 1 and 1 and 0. So I'll just take a quick example. Just remove this. So in the first case we are given n as 2, integer a as 2, which is the number of coins which will be paid for the number of zeros in the subsequence. Number of b coins will be provided for the number of ones in the subsequence. C coins will be provided subsequently for 0, 1 and 1, 0 are provided D coins. So in our case we have the length of the string as 2. So we have to create a 2 length of string where 0 will be given 2 coins, 1 will be provided 1 coin, zeros and 1 will be provided 3, and 1, 0 will be provided 4 coins. So we have to create a string such that we can maximize the value of the sum of all these coins. So if we'll go back, so sample example 0101 has 2 occurrences of 0, 2 occurrences of 1, 2 occurrences of 0101. Actually there are 3 occurrences of 0 and 1 and 1 occurrences of 10. So answer will be 2a plus 2b plus 3c plus d coins. If you look at the constraints, the constraint n can go up to 100, so we can go through all values of zeros and ones for this case. So let us assume that for n we can have I 0 characters, and n minus I will be the value of 1. So we have to generate a string with 0 i's and n minus I ones. Now we can place the zeros at the front, 1 at the back, or 1 at the front, zeros at the back, or few zeros at the end, ones and between, or ones in the front and back and zeros in between. So also there can be a case where there is starts with 1, ends with 0, and there are ones and zeros in between. Similarly, this case will be considered here only. So in total there are 4 cases. If we look at this case, the value of 0 will be I, the value of ones will be n minus I, the value of 0 comma 1. So we can choose any 0 from this first segment and any 1 from this second segment. So as we know, we have I zeros and n minus I ones. So here our answer will be I into n minus I. For each 0 I can choose any 1. So this will be I into n minus I number of 0 ones. Similarly, in this case we can have the same values I, n minus I, and the values of 1 zeros, 1 comma 0 will be I into n minus I. As we have to maximize the number of coins we can collect, so we will check whether we will get more cost for 0 ones or for 1 0. Also you can find out that it is optimal always to choose these two sequences, as this will provide the most number of coins. We are given A, this is A, this is B, this is C, and this is D. As you know, our answer will be independent of the number of ones and zeros which are occurring in between. So we will only consider the maximum among C and D, and will multiply it with our count of zeros and ones. So we can loop over all the ones and zeros in the number of n. Suppose we will go from n 1 to 100. So in the first case 1 to n will go, and for each n we will consider 0 as I, and the number of ones will be n minus I. So our total answer will be A into I plus B into n minus I, where B is the cost for 1, and we will add it with our maximum of C comma D. And we can multiply it with our sequences of 0 ones or 1 zeros. Both are equal to I into n minus I. So this is just a mathematical question. So I'll just go through the code where I have taken the input, and for I have looped over all the iterations where I will consider from 0 to n the number of zeros, and C2 will be n minus 1, and we can directly calculate the cost multiplying it with the max of C and D, as we will consider 0 1 sequence or 1 0 based on the value of C and D. So in the third question we are given an integer n, and we have to construct a permutation of integers from 1 to n. And in a permutation the value always appears only once, and all the values are considered from 1 to n. And we are given a function f of p such that minimum of pi and p of I plus 1 is prime. So we have to minimize the value of f of p. So in the sample test case, if we will assume this case 4 2 1 6 5 3, in the first we can see the minimum is 2, which is a prime, so the value becomes 1. Between 2 and 1 the minimum is 1, so it's not a prime. Between 1 and 6 again it's not a prime. Between 6 and 5 we can find the minimum is 5, which is again a prime, and between 5 and 3 the answer is 3, which is again a prime. So in total there are 3 values where we can find the prime as the minimum. So we have to minimize this number of primes in the array. So we can go one by one. If we'll take the first case where the value of n is 2, so we know that there is only one valid sequence 1 and 2, but the minimum value is 1, so here the answer will be 0. If n is equal to 3, then we can have in total 6 sequences like 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2 and 3 2 1. If we will calculate the value of f of p for each of these 6 sequences, for first one we will get the answer as 2, as the okay, we will get the answer as 1, as the minimum of 2 and 3 will be 2 and it is a prime. For the second case we will also get 1 as the answer. For the third case we will get 0 as the answer, as minimum of 2 and 1 will be 1 and 1 and 3 will be 1, so the value of f of p will be 0. So I will just write here f of p. The answer here will be 2 1 as well, the answer here will be 0 as well, the answer here will be 1. So we can observe that whenever 1 is in the between, we can have the answer as 0, as it both covers 2 and 3. What if we are given n as 4? We just have to add another integer in front of this. So if let us suppose our answer is 3 1 2, we can directly insert 4 in front of this, so our f of 0 will be 0. If our n is 5, now we can have two conditions, as 3 1 2 always yields to 0. We can have one sequence as 4 5 or another sequence as 5 4. If we look at this, the answer of f of p for the first case, this one is also, here we can have 1 as our answer, and here we will have also 1 as our answer. If we suppose take n equal to 6, so we can have the sequence 3 1 2 4 5, and here we have an option of placing 6 in front of this, or we can place 6 in front of the other sequence, which is 3 1 2 5 4 6. If we can observe here, we will find out that the value of f of p for the first one will come out as 2, whereas for the other one it will come out as 1. So it is always better to place the even number at the last index and the odd number in before the last index, such that it does not affect as the minimum. So let us take an case of n equal to 10. So we always know that we start our sequence with 3 1 and 2. Now we always know that after 2, whichever value we put, it will increase the value of f of p, as the minimum will always be 2, because we cannot choose a number less than 2 as it's already occupied. So the next number should be greater than 2. So what we can do is, we can either take the next greater odd element, as all primes are odd, so we can either take an odd element which is greater than 2 or a very higher element. Suppose the n is 10, so here we can take the next greater odd element, which is 5. If we will take 5, the next element we can place as an even element, so the only even element which is lesser than 5 and which is not occupied in this series is 4, so we can place 4 here. And we can observe a pattern, like after 4 we can place an higher odd element, which is 7, and then we can place another even element, which is 6. So we can follow this pattern and subsequently place 9 here, and then we can place 8, and then we can place 10. Similarly, we can follow this sequence for 9 also. Suppose we are given 9 as the answer, so our answer will be 3 1 2 5 4 7 6, and then we will directly place 9, as it will not affect in our answer, as the minimum of 6 and 9 will be 6, and 6 is an even, so this will not increase f of p. So this is just an implementation. I will show you how I have implemented. So for n equal to 2, I have directly printed 1 and 2. For n equal to 3, I will print 2 1 3 as my answer, and after 2 1 3 I will first place the odd number, which is 5, and then the even number less than 5, which is 4. So then you can get the same sequence 5 4 7 6 9 8 and so on. And if I am assuming that my last number is an even number, I will just place the even number. In this case, where I had 10 in my answer, I will directly place after 9 8 the value 10, and then I will get the sequence. So this is the fourth question, where the constraints are a bit low. N is going up to less than 50 and the sum of n is up to 500. So the array A is called sortable if it can be sorted into strictly increasing order after performing an operation n number of times, where we can choose an index I at a positive integer x, and then we can modify ai into ai mod x. So I'll just take an test case to make you understand better. So for this test case, where we are given the value of n as 7 and we are given the array as 5 3 1 4 2 1 1. So what we have to do is we have to calculate all the sub arrays of this sequence where the value of where the array is sortable. So as the constraints are a bit low, we can calculate all the sub arrays by brute force, which will cost us the time complexity as n square. Now we have to if we are given a sub array of length x from L to R, now we have to find whether this array is sortable or not. So we have modified this question and deduced that for each sub array we have to find whether it can be sorted or not. So it's easy to find all the sub arrays. Now we will take a part of this sub array. Let us suppose we take as 5 3 1 4 2 as a sub array. Now we have to find that whether this array is sortable or not. So what we can deduce is that we can always try to reduce the first element as much as possible. So for 5 we can reduce it to 0 as the minimum. Now we have to reduce 3. Now we have two options. We can reduce 3 and keep it as low as 0, or if we can if we'll mod 3 with 2, we'll get our answer as 1. So we have option as 0 1. If we'll mod this with 3, we'll again get 0. If we'll mod get this 1, we'll again get 0. So we have two options, 0 and 1, and also we have a third option that we do not modify this element and keep it as it is, so it will be 3. So in the second case we have three options to keep 3 as 0, 1 or 3. If we closely look at any number n, so what we can do is we can convert n to 0, or we can mod the n number with any, let's say if we'll mod this number with n minus 2, we'll probably get our answer as 2 if our answer n is much greater. So one thing is that we have to observe here, for any greater number, let us assume it as 11, so we can take 11 and mod it with 6 to get our answer as 5. This is the maximum we can do with moduling our answer with the number which is closest to n by 2. For example, for 10 we can mod our answer with 4 so that we can get the answer as 2, or else we can mod the number 10 with 6, which will get us our answer 4. So if you loop it, you can understand that this is the most optimal way of getting the maximum number. So we can find out that if you do n plus 1 by 2, actually it will be n minus 1 by 2, it's the maximum you can get by moduling the number. So you can obtain from the range of 0 to n minus 1 by 2. Also there can be a possibility when you are not reducing the number and directly taking it as n. So for each case we will try to simplify this answer. So I'll just copy paste this sequence 5 3 1 4 2. So for the first number I will reduce it to 0. For the second number, as I have 3 options 0 1 and 3, but choosing 1 is most optimal here, as if I will choose 3 then it can affect the next answer. So I will choose 1 here. For 1 I cannot go greater than 1, so this is not a sortable array. So I can just, let us take another example 3 1 4 and 2, and we have to check whether this array is sortable or not. So for 3 I can reduce it to 0 directly. For 1 I'll keep as it is, as 1 is greater than 0. For 4 I can reduce it to 0, I can reduce it to 1, then I can directly do not make any operation and leave it as it is, so it will be 4. So in all the 3 cases only 4 is the one which is suiting this value and it is greater than 1. So I will keep 4 as it is, but now I cannot place 2 here, as 2 will be less than 4. So this will also be not a sortable array. So our answer will be 3 1 4 is only a sortable array. If you will take 2 then it will not be sortable. So I'll just quickly go through the code. So I have inputted the integer n along with the vector, and then I have the answer variable where I will be looping through all the subarrays. So for it will start from the integer I and it will go from j, and I will take the minimum element, the starting element, as 0, as I can always convert the first element to 0, and this current defines the minimum element it can go after moduling it with a specific integer x. So for example, if the x was 100, so I know that after moduling this value I can grow from the values of 0 to 49, and then I can go to 100. So this is the range of values which I can go for a 100. So if the current value is greater than minimum, I know that the next element will be minimum plus 1. For example, if the first element was 0 and the second element was 100, for 100 the value of current will come out as 49. As I know 49 is greater than 0, I will keep the answer, I will increment the answer as this is the valid sortable subarray, and also I will increment the value of minimum, as now it will be 1. If the value of v of j is greater than minimum, for example, if the array was something like 51, 100, or I'll say that the minimum which was coming before 100 was coming out to be 51. Now I know that the next element should be greater than 51, and I have only one option of taking it as 100. So here I'll directly update the minimum as 100 and then add it to our answer. And if both of these cases are not possible, I'm directly just breaking it and returning my answer. So this is the third question, where I am given an array A of n integers and integer k such that k appears at least once in the array. So in this question we are going to start from some position from 1 to n, and for each position I will create a subsequence of array b. So this b will consist of k plus 1 integer, where we are given some conditions where the first element will be the starting position and all the second positions from 1 to n will be one of the integers present in the array, where this is the condition where a of b of I equal to I. So what does this mean is, I'll just, so a of b of I will be equal to value I. So what we can deduce from this is a of certain position will be equal to I, and b of I will be equal to this position. For example, if the value of I is 1, so that the b of I will be some value which is the position of ones in the array A. So we will take one test case for explanation. So in this test case, the value of n will be 4, n will be 9, and the value of k will be 4. So in this case we can find out the positions of 1. So 1 is present at, I will just write the positions below: 0, 1, 2, 3, 4, 5, 6, 7 and 8. So once is appearing at 0th position, it is also appearing at the 6th position, and it is also appearing at the 8th position. Whereas if we can see the value of 2, it's appearing at the 2nd position, 3rd position and 7th position. For 3, we can see it is appearing at the 1st position and at the 5th position. For 4th, as it is a unique element, it's only present at the 4th position. So our value of b of 1 can be something in the range of 0, 6, 8. B of 2 can be something in between 0, 2, 3, 7, and so on. B of 3 will be 1, 5, or b of 4 will be 1 upon 4. So as you can see, the last element is 4, as we don't have any option to place for other than 4, as it is the only element in the set. What we have to do is we have to minimize the sum possible values for all in the range of bi minus 1. Okay. So if we can assume that our starting integer is 0, so now where we can go, we have an option to go to 0, 6 and 8, and after that we have to go from 0 to another position, let it be 2, 3 or 7. If we are at 6, similarly at 2, 3 and 7. If we are 8, then also we have 3 combination. So we can deduce that whenever we are at 0, we'll first go to the nearest one in the left or at the right. So if I am assuming that I am at this current index 1, I will just copy paste the test case again. If I am assuming that I am in the current index 1, so it will be optimal for me to go from this one to this 2, as this is the closest one. If I am at this one, there are two ways. I can either go to the left one, which is here, or either go to the right one, which is here. Suppose that I have a 3 which is here, so it was optimal for me from 1 to 2 on the right, and then from 2 to 3 in the right. But if the 3 was present in the left side of the array, then I had to go from 1 to 2, which was present in the left side, and then again at the left. So for each index, I will try to calculate its leftmost next bit and the rightmost next integer which is coming here in the array. So for this case again, as I will be starting from 0, first I will be choose from for which integer I have to go. So for this 0, I can either go here, I can either go here, or I can either go here. If I can watch properly, then this one is the closest where I can go. So I will always go from this 0 to this one. After going to this one, I have 3 options. I can go here in the 3rd index, the 4th index or the 5th index, but I know it will always be optimal to go to the closest index. Then after I go here, I have 2 options. I can either go to the left, which is the 2nd index, or to the 6th index. We can observe that at the end we have to always come at the last integer k. So this can be simplified into a DP problem, where I will always start from the end, that is from 4, like here the value of k is 4, so I will start from 4 and then I will go to the next integer. So from 4 I will go to 3, then I will go to 2, then I will go to 1. So I will just find the left and the right bit using lower bound and upper bound. So I will just walk you through the code. So I'll just take the integers n and k and an array. So for each integer, let's assume 1, we will store the positions where it is occurring. So for 1 it is occurring at two positions in the first test case, 0 and 2. So I'll just push back the value for these integers. So we always know that we'll end at the particular integer k. So in this case, as k is 3, the value of tp of 1 will be 0, as in the end we will always be at 3. So while calculating the answer for 2, we will add the answer of 3 along with 2. Similarly for 1, we will add the answer of 2 with 1. So for all the integers from k minus 1 to 1, I will go through all the positions and find this lower bound and upper bound. So I'll directly calculate this upper bound, which will be my right element, and then I will just subtract 1 from the iterator and then print the element and add it to my answer. Similarly, this can find me all the closest values of zeros, ones, twos and threes. After that, I have to go through all the positions from 0 to n. So this will take care of that. So I will grow from 0 to n, and for all the values I will again find the lower bound and upper bound from that position and find the minimum of all among all that and print it on our answer.